Okay, welcome to the Unit 5 review over quadratics. This will be a pretty extensive review. I'm not going to guarantee that it'll be short, but I'm going to try to cover a little bit of everything. You should see some of that occurring down here on the side. We're going to talk everything from combining like terms, graphing, factoring, solving in the different forms, and when or why to use those. Everything through discriminant, radical reduction, and changing forms. So, without further ado, to keep this under some type of time constraints, let's get going. In the first section here, I'm going to do number 4, which is simplifying of polynomials. Write them in standard form. What does standard form mean? Well, that means the highest degree to the left, the lowest to the right, and you should have them sequentially down from there. Now, I picked number 4 over number 3 because sometimes there's some confusion here. You can see that there's a positive. This is one quantity defined by these parentheses right here, right? See these parentheses? Those are nice and defined. Those are separate. They're added together. Addition means nothing in this case to the parentheses. It means you can really just drop the parentheses is what that means. However, on number 3, and I'm not going to do it, but you'll notice, number 3, I'm going to take and draw these arrows. And if you guessed, what this means is that there is a -1 right here that needs to be multiplied to everything inside of this second set of parentheses. We do not do that over here. Not here. Okay? So this one, we drop the parentheses, start combining like terms, and move the highest degree to the front. So for a degree of 4, I'm going to go ahead and box all my terms. Now, normally, if you don't do something to differentiate the terms, you should reorder them and put them together. I like to box them in shapes or lines so you can see them. So that's a degree of 4. That's why it's a square, 4 sides. This is a linear term, so I'm going to draw a line under it. Here's another linear term. And don't forget that the operation that's in front of it, especially the negatives, because there's only two, positive and negatives, the negatives go with that actual particular term. So this is a -4, that's a -6. They're going to go together, and then our constants, I can draw a circle around them because they don't really count as a degree, or they have a 0 degree, whatever your preference is on that. So I've got 3 terms to combine. The highest degree is the degree of 4, so I'm going to start combining terms. So -6x to the 4th and -3x to the 4th is going to give me -9x to the 4th. You can see over here I already got the answer just so you can follow along. And then the next term then is going to be my linear terms. My linear terms are -4x and -6x, which is going to make -10x. And then my constant is 5 and 7, which is going to make 12. I think it also asks us to name it by degree and term. By degree, we look at the 4. That's the leading coefficient, or a leading term, right? Sorry about that. That's the leading term, and so we use the exponent of the leading term to name it, and they all have special names. You have those in your notes. If you don't, look them up. But for a 4, it's called a quadratic, which would be wrong. Over here, it should actually be a quintic for a degree of 4. You don't name anything else you don't worry about any of the other degrees. I don't care that's a linear, I don't care that's a constant. I only look at the largest leading term, whatever degree that happens to be. And then I'm going to name it by the number of terms. And the number of terms here is 1 term, 2 terms, 3 terms. So it's going to be a trinomial. All right, so moving on. Distributive property, you should be pretty solid on. I skipped over that because you should be good. Let's talk about doing a GCF. So GCFs then, I'm going to change my color. GCFs then are looking at 3 terms. Here's 1 term, 2 terms, 3 terms. I've got 3 terms to this polynomial. And a GCF is anything in these terms that's common between all 3. So we're going to go ahead and look at this, and there is something common. We look both by coefficient, which is the number, and then we look by the variables. So there is a common value in both of those. So the coefficient, what's common that I can divide out of -10, 8, and -20, which looks like the max is 2. So I'm going to divide out a 2. I'm going to put that out front. I didn't get rid of it. It's going out front because I'm dividing it out, so I have to show it as like a multiplication going back in. So, and then I'm going to check my variables, and I've got a common y between all 3. I've got 3 y's here, I've got 2 y's here, and I've got 1 y there. So I can only take out the most, which is the least amount of y's that I've got. So this y limits us. So I'm going to take out a single y because I can't take any more than 1 single y out of that one. Now I'm going to write what's left after I divided this 2y out. Notice it's out in front, which means that we're multiplying it back in. So we didn't change anything. All we're doing is moving something common out front. So if I take -10 divided by 2, I get -5. Let me rewrite that negative there. And if I take a y, remember when you do division of exponents, they subtract. So really it's like subtracting 1 from it because that's a single y right there. So this goes y squared. And then I'm going to divide 8 by 2, so that's going to give me a 4, and I'm going to take a y off of that one, so it's going to be 4y. I'm going to divide negative 20 by 2, which is going to give me negative 10, and I'm going to take a y, which means there is no y. So there you go. See, my answers match. Good job. All right, moving down, now we're going to talk about distributing, but we're going to do it with binomials. Binomials meaning two terms. There's one term, there's two terms. You'll notice that all of these have two sets of parentheses. Are there more terms inside the parentheses? Yeah, that's fine, but as we look at it, it says this whole value times this whole value. So that's what we're looking at. And those you're pretty good at, right? You've learned FOIL. I hate FOIL personally. It's an acronym I don't prefer, but if you like it, it's fine. I just choose not to use it. You got to use what works for you. In this case, the ones that I want to talk about is like number 20 here or 21. Either one's fine. Some people get confused when they're asked to distribute, but you'll notice there's no other set of parentheses. Sometimes that confuses you. But what you neglect to see is this 2 here. And that 2 means whatever the quantity is inside the parentheses times itself again. That's what squared means. So I'm going to take and rewrite this, and this is what you should get in the habit of doing. Don't try to do it without rewriting it. You'll most likely make a mistake. It means this, y minus 7 times the quantity of y minus 7. Now it looks like all the other ones, and now you can go ahead and do your FOIL or your distributive. I prefer distributive property. I'm going to go to a really fancy color pink here, and that means that this first term is going to be multiplied by those two terms in the second parentheses, and coincidentally, the second term in the first one is going to be multiplied by 2. So when I'm all said and done, multiply this out. Y times y is y squared. Y times negative 7 is negative 7y. Negative 7y is negative 7y, or negative 7 times y is negative 7y, and negative 7 times negative 7, which is positive 49 because you got two negatives. We're going to combine those middle terms, and you're going to get that as an answer. Now, here's the other reason I picked this one out to do. This is what we call a perfect squared trinomial. Now, you may or may not remember this. It should have been covered in notes previous to this, but if you recognize that you have a binomial and it's squared, you can have a pattern so that you don't have to go through this. Not that this was difficult by any means, but there's a pattern. First term squared, last term squared, negative 7 squared is 49, and then if you multiply the two and double them, so negative 7 times y, or negative 7y times 2 is negative 14y. Does that matter? No, but it makes it easier if you recognize it. That's all that's for. All right, let's scroll down here to a problem that you may see on the test. It's a word problem. It deals with quadratics. It talks about a pool, and the pool's dimensions are x minus 1 and x plus 7. Again, it's a rectangular pool, so here's your pool, here's your water inside, right? And they said that they've got a yard that has these dimensions. Who measures in binomials? No one, not even a math teacher. But for sakes of a problem, you kind of see what's going on if those are actual numbers. So what we can do here is it's supposed to kind of get you the idea is that when we're multiplying binomials, we're really finding area of squares and rectangles, right? That's kind of the whole concept here. So it says, hey, find the area of this by multiplying these two binomials. And if I give you the whole area of the yard, could you tell me how much, and I'll change to green for that, how much grass I need to purchase. So if I measure the area of the inside rectangle and find whatever it comes out to be, and I find the area of the outside triangle and I subtract them, then I'm going to get whatever the area is that I need to grass. So let's go ahead and walk through that then. I'll change colors again. So my first problem is I'm going to find the area of the pool, which is x plus 7 times x minus 1. Again, we just did the distributive property, so x times x squared, x times negative 1, negative x, 7 times x, plus 7x, and 7 times negative 1, or negative 7. Let's clean these two up. So I get x squared plus 6x minus 7. That's the area of the pool. Okay. Now, the only reason I say that's the area of the pool is to find the area of the grass, I've got to take the area of the yard and subtract the area of the pool. That's when I'm done. I'm going to find the area of the grass. That's what that's going to do. So now I got to go find the area of the whole yard, ignoring the pool. So here's the area of the pool, or I'm sorry, the yard. So I'm going to take 4x minus 3, because that's one of its dimensions. And I'm going to take 5x minus 8, which is the other dimension. It's a terrible 8. And I'm going to do the same thing. Distributive property, 4x times 5x is going to give me 20x squared. 4x times negative 8 is going to give me negative 32x. Negative 3 times 5x is going to give me negative 15x, and negative 3 times negative 8 is going to give me positive 24. So let's clean up the middle terms again so we can get down to the actual quadratic, in this case, or polynomial, if you will. So I got negative 47x there in the middle plus 24. Now, this is the whole yard. This is the pool. If I subtract those two, right, yard minus pool, then I combine those. So you'll see it's like a combination of everything we've done up until now. Great problem. Okay, so there's the area of the yard minus the area of the pool, which is going to be this here, x squared plus 6x minus 7. And this goes back to the other problem I talked about. This negative, because we're subtracting, needs to be applied to all three of these terms. So I'm going to rewrite the first term because nothing happened to it without the parentheses. 20x squared minus 47x plus 24 minus x squared minus 6x plus 7. Now I'm going to combine like terms. I've got a squared term here, a squared term here, linear term, constant, constant. When I'm done combining those, I should have this up here. And yep, that's what I'm going to get, 19x squared. And I combine my 47x and my negative 6x. I'm going to get negative 53 squared x. And I'm going to get plus 31 on the end. And that'll be feet squared, because it's an area, right? It's got to be squared for an area of grass needed. All right, moving on. Now we're going to talk about factoring. I wrote out some rules here for factoring, kind of speed this up a little bit. Looks like I'm going to take a look at 5, 8, and 12. Again, don't forget to pause the video. Don't feel like you have to watch it once through. Pause and rewind if you need to, if I go too fast. All right, so for factoring, let's start with the standard factoring. So I'm going to start with 12 first here. Okay, why? Because that's a little closer, and then we'll talk about the differences of 5 and 8. So 12 would be a non-simple form. What's a simple form? One with a coefficient of 1 in the front, and that's where you can see the two values of 12 that combine to make x in the middle. So meaning negative 3 times 4 would make negative 12, and when you factor it, you get x minus 3 x plus 4. That's a simple form. You don't have to do anything for it. You can see it by looking at the c value. However, 12 and some of the other ones that we're going to do have a coefficient other than 1. And those, you have to go through a little bit of a process. So first thing you want to check is if there's a GCF. Nope, there isn't one. 5, 2, and 7 have nothing in common, and there's not an n in all of terms. Is it simplify? Equals, oh, is it simple form? Sorry, is it simple form? No, it has an a value other than 1. Now we're going to do the x. Now the x is only an organizational tool to help us kind of find out what terms are going to work to break up that c value in. But really it's not c value, it's a times c. We just multiply by 1 here, so it's always the same up there. That's why it's the simple form. So in this case, negative 7 times 5 is negative 35. A times c. Don't forget that. The middle term in the bottom is just going to be whatever the coefficient of the linear term. So that's going to be a negative 2. So what two values of negative 35 combine together, multiply to make that, combine, add, subtract to make negative 2? Well, that's not too hard. It's negative 7 and positive 5, right? They multiply to make negative 35. They add together to make negative 2. That's what the x does. It helps you find these two terms. What are those two terms? Those two terms are the middle term that we're going to break it up into. Because what we want to start with is 4 terms. So instead of writing negative 2n, I'm going to write negative 7n, and I'm going to write positive 5n. They are negative 2n, I just uncombined them. And then I'm going to write that negative 7 over here at the end. So now that I've got 4 terms all together, I'm going to break them up in no particular order. It doesn't matter, and I'm going to GCF both of them. So what's common between 5 and negative 7? Nothing. But there is an n squared and an n, so it means that I can pull out an n out of this first set here. So what that means is I get 5n minus 7 when I'm done. All right, I'm going to look at the second term here, and there's nothing common with 5 and 7, and there's not an n between, so I can't do anything with it. Here's the great part. This is what you're looking for in this process. This is called grouping. Now we're factoring by grouping, and when you factor the first two GCFs, what you're looking for is to find the same thing in the parentheses, and we did, yay! So what that means is we're going to re-GCF. We're going to GCF this common term that we just found out, so we're going to take it out front, 5n minus 7. That's the term we GCF'd out, so it means we divided it out. So if I divide this out, what's left? N. And if I divide this out, well, gosh, there's nothing there. But it can't be 0 because 0 makes 0, so it's got to be 1. 5n minus 7 divided by 5n minus 7 is 1. So there you go, matches the answer that we should get. So that's a standard factoring, which takes us to number 5. Do not be freaked out by number 5, right? All it is, it's already in 4 terms for you. Yay, you don't have to do the x. It's already done. It's got 4 terms. Yay, it's one less thing you have to do. Do check, though, that it has a GCF. So you want to make sure that these terms don't have a GCF in them. It would be the first thing that you'd want to do. And you'll notice that there's at least a Q in all of the terms, so you would want to take at least a Q out. All right, looking at 8, and you're like, whoa, it doesn't have a middle term. What do I do, Mr. Hallam? If there's no B, it's 0. But we don't have to go that route. This is another one of those things. I'm going to change my color at this point. It's called difference of squares. It's one of those patterns that we would have learned before, and you should remember this one because I would have said, hey, remember this one out of the 2. So what it is if you look at the first term of, and again, you're factoring, right? If you look at the first term of a polynomial and it's a perfect square, and y squared it's y times y. And if you look at the last term of the polynomial and it's a perfect square, hey, 144 it's 12 times 12. And there's a negative in the middle. If you meet all 3 of those requirements, right? Perfect square first term, perfect square last term, no middle term, and there's a negative between. We check all of those. We get to factor like this. Y minus 12, y plus 12. That's the pattern. You can do the x with the 0. It'll turn out to be the same, but that's really how you should factor those. It's way easier. It's not that hard to recognize, and you should be good at it. Go ahead and multiply it out. If you don't trust me, it makes that one up at the top, right? The positive and the negatives cancel out in the middle. That's why there's no linear term. All right, moving on. All right, how about graphing? We'll combine 2 and 1. We'll graph a quadratic, and we'll graph a quadratic inequality at the same time. So that's what we're going to do. So if we're going to graph a quadratic, first thing you want to do is find opposite b over 2a. What's that find? It finds the vertex, the x-coordinate of your vertex. It finds your h. I'm going to write h here. It finds your h value, right? So that's how you graph a quadratic. You find the vertex, and then you repeat a pattern that makes the shape either up or down, whatever it happens to be. That's a terrible sketch of a quadratic. So let's go ahead and find that first piece. That should be the first thing that we do. So the axis symmetry for this one is opposite b over 2a. I'm going to write it down. B, being the coefficient of the linear term in the middle, is 6, so it's opposite 6, over twice a value, and the a value is -3 in this case. So I get -6 over -6, which is +1. So the x-coordinate of my vertex, so here's my vertex, hk, the x-coordinate is 1. So I can start to write my vertex if I wanted to. I know it's on 1 something. It's somewhere on this line. I don't know exactly where yet, but it's somewhere on that vertical line that I drew there because that's x of 1. So to get the other portion of your vertex, your y value, so you know how high or low it is, you need to plug that opposite b over 2a back into the function. That's what I wrote here, function in terms of opposite b over 2a, which is some crazy math talk. Let's just do it like it is, f of 1. I found out that it's 1, plug 1 back in. So I'm going to evaluate the function at 1. So I'm just plugging 1 into my function here, right? It's going to go back in here. Woo. Ignore, by the way, ignore the absolute value sign, or I'm sorry, the inequality sign for right now. We'll deal with that after. So I'm going to write -3, 1 squared is 1, times 6 times 1 plus 1. This shouldn't be too hard to clean up. 1 squared is 1, which is -3, plus 6, because that turns into 1, plus 1. So these two are going to make +3 plus 1 is 4. So I find out that my y value is 4. So my vertex is at 1, 1, 2, 3, 4, right here. There's the vertex. Now, I need at least 3 points for this, but it is a sketch. So what we're going to do is, I think it says sketch. Does it say sketch? Does it say graph? I don't remember. We'll talk about C in a second. Let's write 4 here before I forget. What's it say up at the top? The directions, graph. It does actually say graph. We can pick any other point in this case because it says graph. If it's a sketch, what I'm going to do is I'm going to look at the leading coefficient. I'm going to look at its degree here. I can get that to erase. I'm going to look that it's a negative, which means it's going to open downward, and a 3 means it's going to be a little bit skinnier. So if I were to sketch it, it would look something like this. And I'm actually going to leave it as a sketch. I'm going to show you what to do if you actually have to graph it. But since it's a multiple choice test you're going to take, you'll be able to work with a sketch. If you're going to do this by graphing, you'd want to take any other point. So you'd probably want to pick something close to the vertex like 0 or 1 and see what y value came out. So you'd want to evaluate the function at like f of 0, which we'll do because it's actually pretty easy. If I plug 0 in here, that whole thing turns to 0. If I plug 0 in here, that turns to 0, and it says that it's going to be 1. So I get another point, which is 0, 1. So 0, 1, hey, I actually graphed the right point there. So I wasn't too far from my sketch. I've got 3 points, which is good enough. It is pretty skinny because that's what that 3 tells us, but there's our graph. Okay, now let's deal with the inequality here. This says, remember, if inequality is if it's a less than sign and it's in standard form, which this is, right? You can say that y represents the solutions, at least this is how I do it. So the solutions, or the shading, is less than the quadratic. This represents the quadratic, right? That's the U shape. So in this case, QUAD, quadratic. So I'm going to shade below. Well, the shade below means that I got to shade inside. So I'm actually shading this region in here. So that's how you attempt the shading. If it was greater than, I'd shade it on the outside. I'd shade out here somewhere, right? I'd shade out here if it was greater than, but it's not, so I didn't. All right, moving on. Trying to keep this short as possible. Not sure how long we are right now, but we'll keep trucking. So now we're going to talk about solving, different forms of solving. First, we're going to solve by square roots. Then we're going to solve by factoring. I think finally down here, we're going to solve by quadratic formula. So we'll check all three. Let's go ahead and stop and talk about which one to use when. Square roots are great if you see a single x squared and no other x's. Notice that there's, well, when you multiply this out, it might get a little crazy, but you don't multiply it out, so don't worry about that. If you see just an x squared and you see it set equal to another number, that's a good chance or good sign to do a square root solving, which only works if it's in that scenario. So if it looks like these, you can use square root solving. Another method you can do if it's in standard form and it is factorable. Not all polynomials or quadratics, sorry, not all quadratics are factorable. Do not think you can factor all of them. Please put that in your head now. You can't factor everything, only certain ones. If it doesn't have, when you're in the x, if it doesn't have two nice values that come out, I'm over here. If you don't have two nice values that come out, then you can't factor it. Now, the quadratic formula, while ugly, works all the time, always. Ew, I don't even know what I'm trying to write there. Always. Okay, so you can use that one no matter what. So if you want to memorize and use quadratic formula exclusively, go ahead. I don't really care. And don't forget, you can always graph these to find the solutions. You know how to do that on your calculator as well. So let's do some square root ones. We'll do number 6 here. Looking at this, and you're like, Mr. Hallam, that's an x squared. It's going to have more than just a single x squared value like number 4, number 1, or number 2. No, because we're not going to multiply it out. That's not the point. What we're going to do is we're going to release this squared or unsquare, or square root this in a second. But first, we need to move this 2. So we're going to divide that away because it's multiplied to this x. And that's really what we're after when we're solving, right? We're trying to isolate that x. So we got to get to it to isolate it. So I'm going to divide this by 2, and I'm going to divide this by 2. Okay. And in dividing that by 2, those are going to cancel out. So I'm going to be left with x plus 1 squared plus 11. Oh, I can't do that yet. I broke my order of operations, didn't I? I sure did. The first thing you really want to do is move this 11 away. I'm sorry, I forgot about that. The reason that you want to move it away is because I would have had to divide 11 by 2, and that's 5.5. We don't want a fraction in this. So if I move this over first, I'm going to get, what, negative 8? Now, when I divide this 2, and I forgot to divide the 11 by 2 the first time through, you have to divide the whole left side by 2, and you have to divide the whole right side by 2. I was cheating. Notice I didn't divide the 11 the first time I did it. Go back, rewind, watch it. That's bad. You can't do that. So you want to clean anything that's next to the squared term or minus multiplication. You want to move that all additions and subtractions away to start. Then once you have that term isolated, divide anything or multiply anything away from that squared term. Next, that's actually your second step. So once you have that divided away, I'm going to go up here and work. So I'm going to get x plus 1 squared equals -4. Now I can actually take my square root. So I am going to square root this whole term. A square root and a square cancel. And if I take the square root of one side, I have to take the square root of the other side. Don't forget rule 2 here. We'll come back to rule 1 in a second. If you take a square root of something while solving, you must add a plus or minus. Not every square root gets a plus or minus, but when you do it by solving, it does. So these square roots cancel, leaving x plus 1 equals plus or minus the square root of -4. Which now takes us to rule number 1, which is I is equal to the square root of 1. So I know we didn't do the whole reduction of radicals yet, but I'm going to break this square root of -4 up into the square root of -1 times the square root of -4. Why did I do that? Well, again, you can do this part in your head, but I'm going to write it out to show you. So taking that, I'm going to break this up into two parts because this is a rule that I know, that if I have a multiplication under a radical, I can have a multiplication of two separate radicals. Why did I do that? Because I know that square root of -1 is I. So this becomes plus or minus I. And this is the square root of 4. But I also know what that equals to, right? What's the square root of 4? 2. And they were multiplied here, so they're multiplied here. So what I get here is plus or minus 2I. I like to put I at the back. So that was a lot of work for that square root. We still have to deal with that x plus 1, so let's drop all that down. We didn't do anything with that yet. Now let's take that 1, because we're solving for x, and subtract it from the other side. So we find out x is equal to something, but where do I put this -1? Well, if you remember complex numbers or imaginary numbers, the real number, rational number, goes in front, and the imaginary numbers go in the back, and that's the one that's attached to the I. So there's your final answer, is -1 plus 2I. Okay, probably won't see one that difficult on the test, maybe something a little bit simpler, but at least that one takes you through everything that you need. All right, so let's go to our second method of solving, which is solve by factoring, which you're thinking I've got to do an x as soon as you hear the term factoring, but don't forget that GCF factoring is just the same. So here's why I bring this up. If we grab number 7 here, first thing you'll notice is kind of odd. You're like, whoa, Mr. Hallam, there is no constant. It ends at a linear term. There's no C value. You're right. If you don't see a C value, remember that it means it's 0, not 1. Don't ever put 1 there, right? 1's for multiplication, addition, and subtraction. The identity is always 0. So there's a 0 there. And then so you ask yourself, okay, I can do this, right? A times C is 0, and the middle term is -10. What two values can multiply to 0 that add to 10? None. That's kind of a clue. But don't forget, now that we've got that out of our way, hopefully you saw that, look, there's two terms and they both have something in common, because the first thing you should do in any type of factoring always is GCF. So let's go ahead and take a common term out of both of these. There's a 2 in both of these as well for the constant. So let's take out a 2. We're going to GCF out a 2, and then we're going to GCF out an x as well. So 2x comes out, leaving me a x in front, and if I take an x out of here, there's no x, and the -10 divided by 2 is -5. So I find this out. There's my two terms. Now, some of these other ones that you're going to factor, you're going to get two solid x something terms. Okay, this one, because we GCF'd it, our first term is here. Right, let me throw this in there, zero product property. That's what we're using, right? We need two linear factors. Well, that's a linear factor, and this is a linear factor. We set those both equal to 0. Like here, we would set this whole thing equal to 0 and solve, and set that whole thing equal to 0 solve. That's what we're going to do. So 2x equals 0. There's that linear factor equal to 0. What's that solve out to be? That's super easy. Divide 2 on both sides, and 0 divided by anything is just 0. So our first intercept, our first solution, is 0. What's that mean? It's the point 0, 0. And if we were to see it on a graph, it'd be right there. Okay. The other one we're going to set equal to 0 is, oops, I don't need the parentheses, almost wrote them, x minus 5. Set that equal to 0. And I'm going to add 5 to both sides. So I find out that x is equal to +5, or the point 5, 0. Remember, we're solving for intercepts, x-intercepts. Right? And if we're solving for x-intercepts, that means that the value you're finding is the x-coordinate of that point. And if it's an intercept, we know that all intercepts share something in common, which is a 0. If it's an x-intercept, it's for the y. If it's a y-intercept, it's for the x. There's a 0 involved in all of them. So this is the point 5, 0, so we'd go out 1, 2, 3, 4, 5. We'd place another point there. We notice that it's positive, so it would go up like this somehow. Yeah, you don't need to graph it, but I wanted to show you what it looked like. So there's your two solutions, 0 and 5. And these ones are a little bit more standard, so if you have questions on those, make sure you ask them in class. All right, and the last one we were talking about is quadratic formula, and it's ugly. It's so ugly, I'm not going to take the time to do it, but you know how to do it. You've done it before. It's not the first time through. If you have questions on those, ask about those in class as well. All right, moving down here, trying to finish up before this becomes 40 minutes. Let's talk about the discriminant. Discriminant is a portion of the quadratic formula. Remember quadratic formula, opposite b plus or minus the square root of b squared minus, I don't know how the song goes, but it's opposite b plus or minus the square root of b squared all over 2a, right? That's the Pop the Weasel song. They did a quadratic formula to it. So that's quadratic formula. The discriminant is the portion under the square root. It is not, I repeat, it is not how you find solutions. If it says the word discriminant, it means that you're finding how many solutions, not a solution. Not, that's right, it's equal to how many solutions. It is not a solution, okay? So you're not finding a solution. If you do the whole quadratic formula, then you're finding a solution. Okay, so in the discriminant, we just do the part under the radical, b squared minus 4ac. So let's identify all of our coefficients. A is 3, b is negative 18, and c is 27. Remember to make sure that it's in standard form before you begin that process. Now that we have those, let's plug in our parts. So we're going to find out negative 18 squared. I'm going to have to grab a calculator. Minus 4 times a, which is 3, and c is 27. Ugly numbers, so let's grab our calculator here. So we'll clear this out. So 18 squared. Why not negative 18 squared, Mr. Hallam? Because it's squared. The two negatives make a positive, so I knew it's going to become positive. So we get 324 minus, we'll just put that all in the calculator together, 4 times 3 times 27, and we're going to find out that it's negative 324 as well. Hey, how cool is that? That makes 0. So what did the discriminants tell us? Well, here's what you know. If it's a positive value that comes out of the discriminant, you have two solutions, meaning that your quadratic touches twice. Once, two. We did not get that. We got the middle one, which says that it touches one solution. So visually, what does that look like? It means that the vertex, however it being open or up or down, touches once. It means the vertex is on the x-axis. And we didn't get a negative number, so it's not imaginary. And imaginary, again, means that it does not touch the x-axis. Okay, good. Moving on to the last couple pieces we've got, simplifying expression. This is simplifying a radical with, hey, it includes a negative, so this is kind of an imaginary number. I went ahead and started this process so we could kind of keep things moving. We broke this up as before, so I broke this up into all the pieces it could multiply up into, negative 1, and then 16 times 2 also makes 32. Why did I pick 16 times 2? Because you're right, 16 is a perfect squared factor. So I can square root that one. That's why I chose it. So really, you would do this in your head, but this is what I'm going to write out. I'm going to break it up into its pieces. And again, I'm going to show the multiplication sign between them, because sometimes students forget that and they try to add or subtract them. They are multiplied at this point. And all points. They'll always be multiplied when you do this. So this, we know, turns into, you guessed it, I. Square root of 16, again, put my multiplication sign back down, turns into 4. And square root of 2 is square root of 2 or some ugly decimal that we'll never ever use, so we like exact answers. So I'm going to rearrange the 4 and the I, because we like to put the I in the back, and it should look like that when I'm all done. Why is there no plus or minus, Mr. Hallam? Because we didn't solve for this, we just reduced it. Right? See the difference? See the difference? We didn't solve, no solving. We didn't take a square root of anything. We just reduced a square root. So that should help you clean that up a little bit. And again, if you have any more questions about i's or how they combine, let me know. We'll do that in class. All right, I think we're down to our last few. Yep, last two. So we're going to talk about converting into different forms. You'll notice this one here is in, this quadratic is in vertex form currently. And it's going to ask us to put it into standard form, which means ax squared plus bx plus c, right? Largest degree to the left, sequentially lower as you go to the right. So they're not in those right forms. How do I do that? Well, if you're going from vertex to standard, you'll notice that this fancy little square right here is the first thing we kind of have to deal with. We need to unsquare that like that. We need to multiply it out. So we need to do the distributive property on it. So that's the first thing we'll do. So I'll start that over here. I'm going to ignore the 1/4 because it's no fun right now. We'll make it fun in a second. And we already did one of these prior. We said if we have a binomial or a linear factor squared, we unsquare squared. We write them next to each other, right? Because it means x minus 6 times x minus 6. And the 4 is additionally no fun right now. We'll deal with that in a second. So I'm going to switch colors, and we're going to do our distributive properties. So I'm going to do that out. 1/4 x times x, and this all goes in parentheses at this point, x squared, x times negative 6, and negative 6x. If you remember your pattern, it's those two multiplied together doubled, so we get negative 12x, and negative 6 times 6 is positive 36. And again, don't forget your 4. Now I'm going to scoot over here. So now I can deal with this 1/4. I'm going to go ahead and distribute it. Yay, love multiplying. So 1/4 times x squared is 1/4 x squared. Sometimes kids stop there multiplying the 1/4 and they don't do it to the rest of it because it's next to each other, I guess. I don't know, but don't make that mistake. So basically it's 12 divided by 4. We all know what that is. You guessed it, negative 3. And there's an x. And 36 divided by 4, does everybody know what that is? Because I don't know if I do, which is 9, right? All right, and then we've got a plus 4. So when we add those together, we get that. Actually, I'm just going to save my time from writing. There's the answer for that one. All right, next and the last, and then I'm going to shut this down, is convert from the following equation to vertex form. But we're in standard. We're doing the reverse. Reverse. All right, in that case, to do this, we need to find the vertex. Opposite b over 2a, we did that once. Plug it back into the function, and then steal. And we all know about stealing, right? Stealing's bad, except for in this scenario where you want to steal the a value. So there's our a value for our vertex form. We can already go and find that. So let's go ahead and find our h. Don't forget what vertex form looks like. Y equals a times the quantity of x minus h squared plus k. That's vertex form for quadratics. So we're going to steal the a. We kind of already know that, right? I'm going to write the pieces we know up top. We know that that's 6. We don't know h yet. I don't know if that's a negative or a positive. We do know that it's squared, and we don't know k. So we've got to find this piece and this piece. That's what we're about to do right here. So let's go ahead and do opposite b over 2a. So opposite b, I almost wrote b again. Opposite b, I'll do it over here. Opposite 24 over twice a, which is 6. So that's a negative 24 over 12, or negative 2. So now we know that. This is supposed to be a negative 2, so guess what? Boom, boom, boom. That becomes positive. Okay, so now that we got that, let's plug it back into the function. So we're going to take and evaluate the function at negative 2. So I'm going to plug in negative 2 everywhere I see an x. I'm going to make that sure that's a negative there. Let me erase this squiggle. Plus 24 times negative 2 minus 7. And that whole business has got to be cleaned up. So this becomes 4 times 6, which is 24. And negative 24 times negative 2, I'm sorry, positive 24 times negative 2 is negative 48. Minus 7. Well, these two here clean up to be negative 24. And then minus a 7 equals, what do we get, negative 31? Looks like negative 31. So our value out here is going to be minus 31. And I don't know if I wrote down our answer to double check it, but that looks correct to me. All right, so at this point, there's some other stuff about switching forms, which we kind of covered everything that you needed in here. Fact form, multiply it out, go between forms. Well, you know what? This is super long. Ask me about completing the square in class. Right now, I feel like I need to end this video because it's way too long. Again, hopefully this is helpful. I didn't do all of them, but I did a majority of what you're going to see in the test, and that should get you going. And then the rest of the time, you can ask those stuff in class. All right, we'll see you later. Have fun. Bye-bye.